Hello all, welcome to Code Hub. Today let us solve the LeetCode study challenge, and the problem is satisfiability of equality equations. We are given an array of strings equations that represents relationship between variables where each string equations of I is of length 4 and takes one of the two different forms, xi equal to ya or xi not equal to ya. Here xi and ya are lowercase letters, that is xi and ya can be ranging from a to z, lowercase alphabets, not necessarily different. They represent one letter variable names. Return true, that is not necessarily different means it can be a equal to a also. So we should note that as well. So return true if it is possible to assign integers to variable names so as to satisfy all the given equations, or else false. That is, if we consider a equal to b and b not equal to a, is it possible to be these two to execute these two conditions? It is definitely impossible, because if we assign a equal to 1 and b equal to 1, then a equal to b gives true, but when we execute b not equal to a gives false, because we have assigned a and b as 1. If we assign a as 1 and b as 2, this will execute true, but this will not be executed. It will be a contradictory for us to execute that condition. So this is the case, this is the problem. We have to check whether we can assign the a to z values with some sort of integers, such that when they execute those instructions, the input equations, they should they should satisfy all the equations. If so, we should return true, or else we should return false. So let us think a little bit how can we solve this problem. Let us take some examples. A equal to a, and then a equal to b, then b equal to c, then a not equal to d. Let us execute these cases. If a is equal to 1, then we can say this as true. We can execute this equation. If then the equation is a equal to b, then since a is 1, b is also should be 1 to execute this equation. And then this equation, b is 1, so we should say this, we should assign this c also to be 1 to execute this equation. Then we want to execute this equation. Since a is 1, d cannot be 1 because a is already 1, so we have to keep either a value which is not equal to 1, so we can have a value which is also equal to 2. So now this case is also executed. So as you can see that I can give some sort of integers, and then I can execute these set of equations. What you observe here is, when I give an a equal to 1, the connected the variables which are connected to this a is also assigned with the same value. Correct? Assigned with the same value. Consider we have a equation a not equal to b. This is the equation, that this is the fifth equation in the equations vector. So we have executed these set of equations, and we have assigned the values respectively like a, b, c, d. Now let us see this equation. When you see this equation, as you can see that a and b is already assigned to be 1, and there is a contradictory way which is not equal. So you cannot definitely execute this equation, because already we have executed an equation which is equal, and we have given a values 1 and 1. So we cannot definitely execute this equation, and therefore we return false. So what you observe is, the connected variable which are to a particular variable, we give the same values, and whenever we see a not case, if the values are previously assigned, it should be equal. If it is not same, if it is same, then we want to say it is false. As you can see that, because whenever I have connected components, I am giving the same value as the previous value. Consider we have a case x equal to z. We will be giving some value to this x. I'm not going to give specifically 1 because a is already given as 1. I am going to give x as 3. Then the connected components with x is z, so I am also giving those value as 3. So whenever I see another case x not equal to z, there is some contradiction because x and z is already assigned a value 3. There is a contradiction with this case, so I will be returning false. So what I will be doing is, we can think this as a graph problem. The step one will be make a graph connected with equal to. What is the step 2? We are going to color the graph. Color the graph in the sense, assign the variables, assign the integers to the connected components. Once they are assigned a value with the connected components, the values with the connected components should be same. Whenever I see a not case, when not equal to case, equal to not equal case, assigned value is same means return false because there is a contradiction. Return false because there is a contradiction. So this is what we are going to implement here. So hope you understand the solution what I am coming to say here. Just try to code, you will be get a better understanding. First we have to make a graph. Before that we can assign we can have a size equal to 26. The size is 26. Now what we can do is we can first declare a vector graph which is of size 26. And now I am going to traverse the equations vector. If my, as you can see that the string will be of size length 4 and the first index will be a lowercase letter and the last index will be a lowercase letter, and in between the index it will be either equal to or not equal to. So we are going to check the first index. So if my equation of 1 is an equal to, then this is an equal to case, so we are going to connect it. Same component, equal to case. So equation of 1 is equal to, what we can say is, we can first get the index. Index 1 is equal to equation of 0 minus a, int index 2 equal to equation of 1 minus a. I have the index 1 and index 2. Now I have to connect the graph. Since it is an undirected graph, I am going to say graph of index 1 dot push back of index 2. Just copy paste this, index 2 index 1. So now we have the same connected components. After which what we are doing is we are going to assign the colors. How we are going to assign the colors? We are just going to do a DFS function. So DFS, we are going to do just DFS for those components, and we are going to color the graph. Color or assign integers to the connected components. So for that what I can do is I can have a vector in color of size 26. which is initially initialized with -1. So now I'm going to color the graph. Int I equal to 0, I less than 26, I plus plus. For each connected component, I'm going to color with the color I. So I'm going to color with this color I only. So I'm going to call this DFS function and I'm going to pass the graph, then the color vector, then the ith color and the ith index. So here we can write a private function. This is a void function DFS vector int ampersand graph and color vector int sorry vector int color and int I will be the node and this I will be the color int color, or I will name this as colors vector. This is my color. Or else I can name this as values to do more easy. So this vector is going to be considered, can have those values for each A, B, C, each lowercase letters. So this is nothing but val. Val is nothing but it is going to be. So I'm running a for loop from 0 to 26 and I'm going to pass this values vector and then the graph and then this I is my node. I is my node and this I is nothing but my color. So this is the values vector. So now what I'm going to say is if my values of I is not -1, if it is not visited, not visited cases, already the values of node is -1. If it is only -1, I'm going to enter it and I'm going to color this values of node with this particular color. After coloring this node, I want to color those neighbors also. So for auto neighbors in my graph of node, I'm just calling this DFS function graph values values neighbor and then the same color. I'm going to assign that with the same color because it is connected with this particular node. So I have called the DFS function. Now what I'm going to do is I'm going to just traversing the equations again. Equations. Now I have to check for the equations of 1 to be not equal case. If it is not equal, then I want to get the same index 1 equation of 0 minus a and int index 2 equal to equation of 1 minus a, and I have got those particular index and I want to see their colors. If my color of index 1 is equal to my color, this is values. If my values of index 1 is equal to my values of index 2, we are taking a not case, but we have got the same values, so we have to definitely return false here. If or else at the end of the day I'm going to return true if it passes all the equations. So hope you understand the code. Let me give a dry run and then see. It got some runtime error. So let us see what is the error first. Sorry, actually the first and the last is the lowercase letter, so 0 and 3 and even 0 and 3. So it is accessing some other character, so only it is giving an runtime error. Superb, it got accepted. I will give a try run. As you can see that I have built a graph here for equal to case there, so that I'm saying that they are connected components. So for those connected components, I'm giving the color I to those connected components. I'm giving the color I represents, I'm giving those connected components the same values, and again I'm traversing the equations and checking for the not equal case. And when I'm checking for the not equal case, if those values are pre-filled, if those values are equal, then I will return false, because it is a contradictory case, right? Already I have filled the values with the same values, and I am checking for a not equal equation. It is contradiction, so we will return false, else finally we are going to return true. So let us try to submit the code. Should get accepted. Yeah, it got accepted. Hope you like the solution, and let me know in the comments. If there are any suggestions, always welcome. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.